Hello and welcome to the second video of the D1 chapter Algorithms. Question on the screen, pause now if you've got time, give this a go. What does this algorithm do? It's not at all clear unless you are familiar with the method it's trying to do anyway. So what I'm going to do is do a quick trace table. We've got A, it says let A equal 0, input x, y. So we're going to need some values. Let's say x is 6 and y is 7. See what happens with that. And then the next one, is x even? That is a question. In this case, yes. If it is, x equals x divided by 2, 3. And then we go on and we do y equals 2 times y, 14. Back to is x even? X is not even now, no. Therefore, a is equal to a plus y. 0 plus 14 is 14. X is equal to x minus 1. That's 2. Is x 0? No. X is not 0. And then we do x is x divided by 2. That's now a 1. Y is 2 times y. That's 28. Brings us round. Is x even? No, x is not even. So we replace a with a plus y. 14 and 28 is 42. Then x is equal to x minus 1. That's a 0. Is x 0? Yes. Output a and stop. So with our input 6 and 7, it still might not be entirely obvious what this is doing. But 6 times 7 is 42. If you try this with a couple of other numbers, you'll realize that this is giving you the multiplication of your input values. This is a flowchart form of what's sometimes called the Russian peasants method of multiplication, which is given as a written algorithm in one of the examples in the textbook. In this video, we're going to look at the bubble sort. Read the question carefully is obviously something you should do in every exam all the time. But with the bubble sort question, because this is sorting elements into order, you need to be aware, are you doing ascending order or descending order, or if it's letters or words, then alphabetical order. It's very easy just to default to ascending order. Make sure you know which of these you're doing. You might need to show the comparisons or swaps. That might not make sense yet, but as we get into what this actually is, that will make sense soon, of a full pass. But it's more likely that you'll just need to show the end result. So read the question carefully. Do you need to show these or not? If you do, you must show them, otherwise you're going to lose marks. If you don't just do it just in case, because it's quite time consuming and you don't want to waste that time in the exam. So be clear, do you need to show these for one full pass or not? You'll never need to do more than one full pass with this. And hopefully you won't even need to do that, just the end results. But you might not even need to do the full bubble sort. Sometimes you just need to do 2 or 3 passes. If you do have to do a full sort, then at the end of the sort you should make a statement to show that you finished. Something like, the list is in order. So let me say it one more time for good measure. Make sure you read the question carefully. Don't waste time doing things you don't need to do, but make sure you do get in all the bits that you need in order to fully answer the question and get all the marks. Okay, the bubble sort algorithm itself is here. Moving from left to right, compare the first and second items in the list. If they are in order, leave them. If they're not in order, you swap them. Then you compare the second and third items, where it's easy to jump over the second because you've kind of already used it in this first comparison, but don't do that. You're comparing the first two, then that second one, whether it's the same or whether it's swapped, you're comparing it with the one next to it. And you're going to do that all the way along the list of items until you get to the last item in the list. All of that is one pass. And at the end of that pass, whether you've had to write out all the comparisons or not, you should write the updated list after that first pass. Then I've put a little gap here because, as mentioned, you won't always need to do all of this in the exam in terms of showing your process, but whether you show it or not, you then continue making passes until a pass has no swaps. And if you get that far, then the bubble sort is finished and the list must be in order. This is the first of many algorithms that you need to remember. If this comes up as a question in the exam, you need to be able to do it without referring to what I've got on the screen here. So to give an example, use a bubble sort algorithm to arrange this list into ascending order. Underline that to make sure I've got that in my mind. We're going from small to big. Now this is one place where a lot of students don't like this module, because as a human, you can just do this. You can go, oh, 19 is clearly the smallest number in the list. That should go first. But you need to go back to what I said in the last video. Think like a computer. You can't do that. You need to go step by step by step. So I'm going to show a full pass here, which you might not need to do in an exam, but you might. So I would write out my list, because in the exam you might have the question in the question booklet and it might not be written out as a list in the answer booklet. So that would be my first one. And then to indicate where my comparisons are, I'm going to circle them. So I'm comparing 35 with 23. For ascending order, that is not in order. So I'm going to swap them. The rest of the list is unchanged. Now I need to compare the second and third items, and you can see the 35 is in both comparisons because it's swapped. This is in order, so I don't swap them. They stay where they are. The rest of the list is unchanged. Then I compare these two. Clearly not in order. They swap. Then the next two, also clearly not in order. Nothing else changes, but they swap. I compare the last two, also not in order, so they swap. And this is after the first pass. So this bit here is the comparison and swaps. If you need to show one full pass, this is what the examiner is expecting to see. If you don't need to show all of the comparisons and swaps, then you can delete all of this, but you must still show this line here. What I'll do is the second pass underneath, without all of that process shown, but you still need to do the same thing. So we're looking at the first two. They don't need to swap, so I leave them. But I'm not going to write 35 yet, because 35 is part of the next comparison as well. So I compare these two. That will swap, so 19 is now in this position, and 35 has kind of bubbled along. Then 35 will be here, compare it with the 22, that will swap as well. So 22 is here, 35 continues its little bouncy bubble. 35 with 39, that won't swap, so 35 stops here. That stays how it is. Now we did have some swaps in that pass, so I can't stop yet. I need to make a third pass. Don't think I'm going to have room to squeeze it all on here, but I'll try. Comparing these two, 19 here, that puts 23 here, comparing that, 22 goes here, 23 moves on, 23 and 35, no, so 23 stops here, 35, 39, 45, we can see they're all in order. Third pass is finished. To finish off the bubble sort, you must make another pass. You can see it's in order, but that's not enough. The algorithm says keep going until there are no swaps in one pass. Now, I don't need to actually do the comparisons myself, so in terms of being in an exam, you can put thinking like a computer to one side for a second and just write it all out. And then on the side, or underneath ideally, you would write no swaps, therefore sort complete. That would be written underneath in an exam down here, and then I would be finished. As mentioned, you might not need to do all of this. This is one full sort, including showing the comparisons of the first pass. It might just be that you need to do just these two rows in an exam. Or you might need to do 3, or you might need to do all of them and put the completed statement on the end, or you might have to show the first pass. So I've shown here what would be the most you're likely to be asked to do in an exam. Next example. Use a bubble sort algorithm to arrange the letters of 7 into alphabetical order. S, E, V, E, N. So I won't do a full comparison. I'll just do the first pass, the result of the first pass. S and E, not in alphabetical order, so they would swap, and the E will go here. I can write that, but I shouldn't write the S yet, because that is part of the next comparison. S and V is in order, so then I've got V and E compared to each other. That will swap, and then the V is here, V and N will also swap. Second pass, E and the S is in order, S and E, that will swap, so the E is now here, S and N will also swap, and the V is at the end. Third pass, E and E, so we've got N, S, V, no swaps, therefore sort complete. Third example, use a bubble sort algorithm to arrange this list into descending order. There we go, there's that word that will trip some people up. So we've got 1, 2, 3, 4, 5. First pass here, comparing 1 and 2, that will swap. So the 2 is here, the 1 is here, comparing 1 and 3, that will swap as well. And then the 4 will swap, and then the 5 will swap. And what this algorithm is doing, if you haven't realized yet, is it's taking the number or the letter that is going to end up in the final space here, and it's sort of bubbling through the list. And if it hits one that is further in the extreme, it stops, and then that one bubbles through until this final position is sorted after the first pass. After the second pass, at the very least, the final 2 positions will be fixed, and then after the third pass, the final 3, and so on. So what I'm showing here is the maximum number of passes that you would need, because we're completely changing the order from ascending order to descending order. So the 2 will bubble through next, and it will finish here. The third pass, the 3 will be in the right place. Fourth pass, the 4 will be in the correct place. And then the fifth pass, to ensure that we're finished, shows no swaps have been made. So at most you'll need n number of passes, where n is the number of items in the list. And of course the smallest number you'll need is 1. If they're already in order, if we were sorting it into ascending order, then the very first pass would end up with no swaps and we would stop there. Final example is a past exam question. The list is to be sorted into descending order. Starting at the left-hand end of the list, perform 2 passes. So we just need 2 passes. We're not going all the way until it's finished. Through the list using a bubble sort, write down the lists that result at the end of the first pass and the second pass. So I don't need to show all the comparisons. I just need to show 2 passes. So I've got the list at the top of the screen there. First pass, we're comparing these two. We want descending order. So for descending order, that is in order. The 2.6 stays where it is. 0.8 is going to bubble along. 2.1 here. 1.2 here. 0.9. Each one is being compared with this 0.8 as it goes along the list. 1.7. 2.3. And then it hits 0.3. So the 0.8 is not smaller than that. And now the 0.3 is going to move along. 1.8 takes its place. 2.7, and the 0.3 ends up at the end of the list, which is where it will stay. That's our first pass. Second pass, 2.6 is still bigger than 2.1, 2.1 is bigger than 1.2, 1.2 is bigger than 0.9, but 0.9 is not bigger than 1.7, so that starts moving along the list, but then it is bigger than 0.8, which now starts moving along the list. And 0.8 is now in its final position, as well as 0.3. So I've done 2 passes, that's all I needed to do. BI is finished. Write down in the table in the answer book, which I've copied down here, the number of comparisons and the number of swaps performed during each of these 2 passes. So the number of comparisons, 1, 2, 3, 4, 5, 6, 7, 8, 9 comparisons with 10 items. The number of swaps, the 0.8 swapped. That's 1, 2, 3, 4, 5, and then it didn't swap here, but then this swapped 6, 7. There were 7 swaps. Second pass, the number of comparisons is 1 fewer, because we know the last item is in its correct place. And the number of swaps that we had, comparing here, this was where the swapping started. So that went 1, 2, and then that did not swap, but this did, 3, 4. So there were 4 swaps in the second pass. That's the bubble sort, and that should be enough for you now to have a go at the questions from exercise 1C. And maybe I'll see you for the quick sort.